Okay, hello everybody. So part A, write down a list of two linear equations in two unknown variables. Okay, so part A is the formula. Let's say like this, and maybe y equals 3. Okay, so I just invented these numbers, but the key is that I had two variables, x, y, and I have two equations, and there's no x squareds or xy or xy to the third, none of that, just linear, okay? Part B, draw and label a picture of its solution, okay? So I'll do part B here. So there's two variables, so we're in two-dimensional space. And let's see, 2, 3 is the first normal vector, and then -3, 1 is the second normal vector, and they're both shifted off the origin. So, I don't know, maybe 2, 3 is like that, but then I have to shift it off the origin some amount, so I'm going to say like this. Right, so this is the vector 2, 3, which is 90 degrees. It's supposed to be 90 degrees. Okay. So then I have the vector -3, 1. -3, 1 is like that vector. But I shifted off the origin in the direction of this vector. So maybe here. Okay, and this is supposed to be 90 degrees. Okay. And yeah, the vector 2, 3 was that vector, 90 degrees. Okay. Now its solution is here, where the two meet. The solution. The solution, we could even give it a name. Oh, not P of, but P equals x comma y. Not P of x, y, that P would be a map. No, that's not it. Okay. Part C. Write the solution as the preimage of 0 under a map. Okay, so I'm going to use words first. This is part C. The solution, P equals x comma y, is the preimage of, well, the 0 vector actually. So this 0 wasn't the number 0. It has to be the 0 vector in order to get the preimage of a map. The preimage of 0, 0, under what map? Now I'll use formulas. The map sending x, y to the point, well, 2x plus 3y minus 5. So when that's 0, when that is 0, we have satisfied the first equation. And then the second equation becomes minus 3x plus y minus 3, so that when this is 0, we have satisfied the second equation. And if we're the preimage of 0, comma 0, that means both this and this are satisfied, and so we are the solution. That's it. That's C. Part D. Write its solution as coefficients of a linear combination of vectors. Okay, so this is yet another way to write its solution. So I'll put in words first. The solution, sometimes I write SOLN for solution. The solution, P equals xy, is, or maybe I'll say, are the coefficients of this linear combination. And then I'll write the linear combination I need. Namely, this vector plus this vector equals that vector. So x times the vector 2, oh, that's a bad 2. 2 minus 3 plus y times the vector 3, 1 equals the vector 5, 3. Okay, so this is a vector equation. It's an equation among vectors. And the solution of this system of equations is equivalent to finding the coefficients that make this linear combination true. So we see now 3 different formulas and a picture for a linear system. All of this generalizes to 3 dimensions, 4 dimensions, 5 dimensions in exactly the same way.